Hello geometry students, if you're watching this video, it must be 2025, so happy new year to all of you. Today in this first video, I wanted to just give you a quick overview of what you'll be doing today in class and also tomorrow in class. I will not be here both the 2nd and the 3rd, but I will be back with you Monday, January 6th to move on and finish our final 2 weeks of the class. So for this video, I want to talk quickly about what you're doing this week first, and then I'm also in this video going to do a quick overview of what we were learning right before winter break, because it's been almost 2 weeks since we've had a chance to work and finding trig ratios. So as you can see, you are currently watching this video right here. It's like I have a link to the future. No, it's no link. But after this overview video is finished, I would like you to go back to the practice that we were working on just prior to break. And that is this worksheet right here. Trig ratios of special angles. Part 1, it says use unit circle, but as we talked about, you're going to have a choice between unit circle and trig toolbox. That's your call. But you can use the unit circle for these 10 if you want to practice that. Then numbers 11 through 26 are the remaining ones that we worked on prior to winter break. So some of these should have been started as we started them on that Thursday right before break. From there, after you are finished that, then we're going to move on to some special cases. And so the first of those special cases, we are going to talk about coterminal angles. And what you'll need for that is this note sheet here called coterminal angles. There will eventually be a video link right there where my mouse is. I'll be recording that video very shortly. And we'll go through those examples as well as some of the examples back on our notes, which we'll talk about here in just a few moments. After that, then you'll go back to that same practice worksheet that you worked on 1 through 26, and questions 27 through 32 will be practicing those special angles. Then, if there is time at least, you will have the opportunity to work on Delta Math trig ratio evaluation practice. Now, this is an overall review. And actually, one suggestion I'm going to make is that if you actually do get all the way here and finish task 3 today, you might actually want to go ahead and just finish all the content and move to Friday, and then you can save the Delta Math for the end. So I'll leave that up to you if you want to practice it now or push ahead to Friday if you have time. But regardless, that is our Thursday plan. And just as mentioned, Friday's plan will make sure you finish everything from the Thursday lesson plan. So if you do have some leftover work to do, make sure that gets done first, because we're going to continue building with the second special case, which is quadrantal angles. And this will be a check-in with Mr. Field as he will walk you through how to deal with those angles at 0, 90, 180, and 270. We've been skipping over all of those up to this point, and he will now address those concerns and talk about how we deal with those problems. That same practice worksheet that you've been working on, the 1 through 26 and then the 27 to 32, there is now then a set from 33 to 38 specifically addressing quadrantal angles. And that will conclude the trig ratio lesson. At that point, the remaining time that you have on Friday is to help you prepare for our mastery check that we will most likely be taking at the end of class on Monday when I'm back. No promises on that. I got to check in with you on Monday and see how everything is going. But there is a practice on that same exact worksheet, 39 to 54, which is essentially a mixture of what we did pre-winter break, and then mixing in those coterminal and those quadrantal angles as well. On top of this mastery check review, 39 to 54, you once again have that Delta Math that you can use as well to practice this. Remember that these skills are to be done without a calculator, and that the only resource that you have is either your memorized trig toolbox and or your memorized unit circle, which we'll all talk about in just a moment. And like I said, we will have that mastery check. And unlike other mastery checks, this is not fully open note. The only notes you will be able to use is a trig toolbox or a blank unit circle that I will have pre-printed for you. We'll talk more about that on Monday, of course. So right now, your focus today and tomorrow is primarily on the practice and getting yourself back up to speed and comfortable finding these trig ratios. So if you're looking for a little review, well, I'm here for you to help you with that. So here are the notes that we took last Wednesday and Thursday prior to winter break. And I showed you 2 different philosophies. The first idea is that we can find any of these special trig ratio angles by using our trig toolbox, memorizing our special right triangles, the ASTC All Students Take Calculus, knowing our key radian values converting to degrees of 30, 45, and 60, quadrantal angles, which Mr. Field will address in the quadrantal video tomorrow, and lastly, our true and tested SOHCAHTOA. However, some of you, as I've spoken to, like the idea of using the unit circle instead. And what's great about this unit circle is that as long as you are able to memorize, let me go full screen here for a moment, if you can memorize quadrant 1, then you can memorize 2, 3, and 4 as long as you take note of the signs of the answer. So I'm not going to fill this all in, but the core thing that you have to memorize is that we know that 45 degrees, which is pi over 4, is 1 over root 2, 1 over root 2. And then for 30 degrees, we are going to have 1/2 as my y, and then root 3 over 2 as my x. That's pi over 6. And then over here is pi over 3, 60 degrees. And then what you do is you really, if you just memorize the 30, you just flip-flop it, and now you have your 60. And so once you have those, we can use symmetry to basically say all the red ones are going to have the same x and y coordinate. I'm just going to do the reds for this video. But all of these 4 points will be 1/2 comma root 3 over 2, 1/2, let me scroll down, root 3 over 2, 1/2 root 3 over 2, and then only difference here is in quadrant 2, we get a negative x, quadrant 3, we get a negative x and a negative y, and in quadrant 4, you get a negative y. You rinse and repeat for the 45, you rinse and repeat for the 30. And then in terms of the quadrantals, remember that this is a unit circle with radius of 1, so we go to the right 1, up 0, we go over 0, up 1, we go left 1, up 0, and we go over 0, down 1 to get those quadrantals. And once again, we'll talk about those in another video. Now, once you've made a decision on which tool you want to use, you will either complete that blank unit circle, and now you will have all the completed ones there. There's a picture of it. Or you will have that toolbox. So let's just take a moment and go through a couple of these. And again, this is a repeat of our lesson. So if you are at this point feeling like you remember this and you want to move forward into your practice, you can at any point. But the remaining minutes of this video, I'm just going to walk through set 1 and set 2 from our notes again if you're looking for a second resource. So what I'm going to do is for parts A through C is I'm going to use the trig toolbox, and then for D through F, I want to use the unit circle. So depending on which philosophy you're moving with. Either way, at the top here, you will see I have that resource. So let's talk about it. So what I do for the trig toolbox is when I look at a ratio, I ask myself 2 questions. The first question is I look at the angle and figure out what quadrant I am in, because that will help me determine whether this is a positive or negative answer. The second I look at is what the reference angle is, because that will actually tell me the value of the ratio. So for pi over 6, we know that this is in quadrant 1. We know that all trig ratios in quadrant 1 are positive, so this is a positive answer. I know that pi over 6 is a reference angle of 30 degrees, therefore the tangent of 30, so there's 30, opposite over adjacent, is 1 over root 3. And that's going to be my final answer. You can leave it unrationalized, or if you want to leave it as root 3 over 3, either or is going to be acceptable here. In letter B, we look at 120 degrees. I know that this is in quadrant 2, and in quadrant 2, sine is positive. And so because of that, we can actually say that, well, this is going to be a positive answer then by default. 120 has a reference angle of 60 degrees, as it is 60 degrees away from 180. So the sine of 60 is what I'm actually looking for here, which is root 3 over 2. Now, you don't have to write the plus, by the way, in your answers. I'm doing that just to emphasize that we're thinking about the signs of these answers. And then the last toolbox one I'll show you for this first set, 5 pi over 6, we know that that is also going to be in quadrant 2, but in quadrant 2, cosine is actually negative, so we'll throw that in there. And pi over 6 is a reference angle of 30. Once again, our key radian values help me really speed that process up. And so the cosine of 30 is what I'm really looking for, and the cosine of 30 is root 3 over 2. Now, if you're looking at those and say, but I would rather use the toolbox because I would rather use the unit circle because I can memorize that values a little bit easier. Well, let's take a look at those real quickly. So let me just move this text out of the way, and we'll do these next 3 using the unit circle. So what's really nice about this is if you put the time and the effort to memorize the circle, you're literally just gathering the answer from that unit circle. So 7 pi over 6 is going to be right here. And sine is always the y value. Remember, cosine comes before sine in the alphabet, X comes before Y in the alphabet. This is how I remember sines and cosines in that situation. And so in this case, sine of 7 pi over 6 is just the Y value. So right away, we just say -1/2. Whereas if I move now to tangent, here's the challenge with 330. So here is where it's located, right there in quadrant 4. And we have an X and a Y. Now the problem with tangent is we have to actually create the ratio Y over X. And so in this case, this would be -1/2 over √3/2. We create a complex fraction, so it's really -1/2 times dividing by a fraction is the same as multiplying by the reciprocal. And so the tangent of 330 is just -1 over √3. And then the last one for this first set, cosine of 240, that's going to bring us over right here. And remember that cosine is the X value, so our answer here is simply just -1/2. So that is the basics. Now, when we move down to the reciprocals, I'm probably not going to do all 6 of these. Video's already running fairly long, so let's speed this up a little bit. And depending again on which philosophy or idea you're going to use, what I'm going to do is always remember what my reciprocals are. And I'll just make a little note of that right now. So for example, secant reciprocal is cosine, cotangent is tangent, cosecant is sine. We got sine again, we got cosine, we got tangent. So I make a little note of that. Now I write it down on the screen here, but you don't necessarily have to write that down. We're going to treat this exactly as if it was for A, cosine of 5 pi over 4, and then we're just going to flip the answer. So if I'm using the unit circle, as I will here in A, 5 pi over 4 is going to be located right here. Cosine is the X value, so it's -1 over √2, but since it's secant, we're going to write it as -√2 over 1, or just -√2. For cotangent of pi over 3, well, let's talk about this from a toolbox perspective. I know that this is in quadrant 1, so that's a positive answer. Over 3 is going to be a 60-degree reference angle, so I want to find the tangent of 60, but then flip my answer. Tangent of 60 is √3 over 1, so I flip that to say that the answer is 1 over √3. And then for cosecant of 135, again, whichever perspective makes most sense to you, here I'm going to talk about how 135 is in quadrant 2, sine is positive in quadrant 2. 135 is a reference of 45, and that therefore the sine of 45 is 1 over √2, but I will flip it to say positive √2. So that is all the work that we did prior to winter break. We looked at the basics, the bread and butter of this, the majority of the questions you're going to see, as well as talking about reciprocals. And so the practice that I want you to do based on that we started prior to winter break, but now I would like you to take more time, are the problems 1 through 26. Take an opportunity to work on those. And remember that you can use your calculator as like an answer key for this, but just remember that these are specific skills that we are to do without the resource of a calculator, and that you should be using either a unit circle that you've memorized or the trig toolbox that you are able to generate in order to answer these questions. So once you had a chance to work on that, then you can move on to today's special case, which is coterminal angles. And then if time or tomorrow, move on to the other special case, quadrantal angles. And then we will sum it all up at the end of Friday and when I'm back on Monday. So that is your overview for the week. If you have any questions, you can certainly email me. I'll be checking my email once a day. So if there's something you need to address, let me know. Other than that, I hope you have a good, successful 2 days here in class, and I will see you back Monday, January 6th. Have a great day, guys.